Hello and welcome to Tinkerkit Lab 3. Today we're going to build a circuit with a photoresistor. This circuit will look very similar to the one that we just did with a potentiometer. This one, we have a little light sensor. Move the light from it, turns on, and we let the light go back, turns off. Right, so let's take a moment and how this. So, half of this circuit should look familiar, should look very much like the last couple of circuits we've done. And the other half should look comfortable with what we've done, but a little different. So let's start. We're going to use 1, 2, 3 black wires for grounds. We use 1, 2 red wires for 5-volt positive. Use 1 blue signal wire. I'm going to use 1 yellow signal wire. 1 LED. I've chosen to continue using the red LED, but you can use any color you'd like. The same or another 330 ohm resistor. Once again, this is orange, orange, brown, gold. We're going to use the photoresistor. Looks something like this. You'll notice a squiggly line across the top. This is essentially a light-sensitive variable resistor. We are going to use 1 10 kilo ohm resistor. This is brown, black, orange, gold. And of course, we'll use a breadboard in the Arduino. Start by making the circuit. To start, we're going to work with the familiar part that we've already know. If you already have this part of the circuit built, there's no need to replace it. We're going to take the red LED. Just like before, I'm going to put the positive in row 2, column A. I'm going to put the negative in row 1, column A. I'm going to take the correct resistor, my 330 ohm resistor. I'm going to bridge from 2C to 2G. Remember that no power goes through this gap right here. Bridging across. Going to take my black jumper wires. I'm going to go from 1E over to any of the common grounds, far right hand side. Plug those into the Arduino in a minute. I'm going to take the yellow signal wire. I'm going to plug it in to 2I. And for those of you who have looked at the circuit versus those of you who have read the code, there's a nasty little surprise in there. The circuit diagram shows you putting it in pin 13. However, the code calls for pin 9. We're going to use pin 9 in the Arduino. If you rewrite your code to use pin 13, it'll work just fine. But in future uses of the Arduino, you'll notice that some of these digital pins over here have a little squiggle next to them. There. This indicates that these have EWM, which stands for pulse width modulation. And it'll allow us to kind of fake an analog curve. But we'll get into that later. So Pin 9. Clean up my map here. But now I'm going to take my photoresistor. These are non-polar. They don't care which way you put them. You will notice that they have quite long legs on them that really like to bend, so be careful. I'm going to put one of the legs in 28A and the other one in 24A. Make sure that when it's in there, that the legs are not touching each other. You don't want it to short out across the pins. We're going to take our 10K resistor. In this case, I'm going to go from 28C to 30C. Being a little. Oh. This will complete our voltage divider. The photoresistor will be the other part of our voltage divider. This is go through here. Denote that this is a variable resistor and this just a normal resistor. And we will take our signal from in the middle, which will be the middle pin of our circuit here. So we're going to do that now. I'm going to take the blue signal wire. I'm going to plug it into 28E. I'm going to bring that back over to analog 0, just like we did on potentiometer. We need to complete our voltage divider. So I'm going to take a black ground wire and I'm going to go from 30E. I'm going to bring it over to the common ground rail. I'm going to take one of our red power wires here. I'm going to go from 24E to our positive power rail. I'm in the positive rail here with the red one and the negative with the. Almost done here. We just need to get power to our common rails. I'm going to start with the ground wire. And I'm going to connect anywhere along this ground common. I'm going to bring it over to the Arduino to the ground. Once again, any of the grounds on your Arduino, they're all the same. So it may make more sense sometimes to go over to one of the grounds on the right-hand side, either the ones on the left. Take my last red power wire. I'm going to go from the red common rail to the 5-volt power source. And I'm going to double check that in the wrong port, I had plugged it in ground, so now it's in the 5-volt power. Circuit should something like this. Okay, so now that we have our circuit built, take a look at the code. So once again, if you go through and you look at the circuit diagram here, this yellow signal wire goes into pin 13. I have put this into pin 9. Moment. So I've taken the liberty of already copying my code from down below. into another M file. I have already connected my Arduino. But just as a reminder, if we do A equals Arduino, parentheses, apostrophe, in COM port 3, you will different, comma, apostrophe, uno, apostrophe, parentheses. This won't connect. It'll give me an error because I already have it connected, but this is how you connect. Mac users, it's a little bit different for you. At this point, you should have figured out. Okay, I'm going to go ahead and click run on here. Start my code. If everything goes right, and something didn't. Okay. Okay. Open my code. Great reminder that things don't always quickly. Oh. So right here, I had previously changed it to pin 13 to test that pin 13. And then in the process of changing it back to pin 9, I had deleted 9. A perfect example of small things in MATLAB messing up your. So now that I've changed it, see down below, my light variable is changing. And as I move my finger over top of the photoresistor in a way, you can see these numbers change. Now, these photoreceptors are sensitive almost the whole way around. So in order to get it completely zero, you have to bring it down quite dark. But just putting your finger over the top should be enough. Off. Have a quick look again. Circuit. So you can see as I put my finger over the light, turns on and turns off. Okay. Switch back to the code, and we're just going to kind of go over what the code is doing. So once again, this is a well-commented code. Take the time to read through it. At the very top, we define a sensor pin as A0. This is very similar to the potentiometer we used in the previous lab. Instead, at this time, we're just using photoresistor. But the Arduino and MATLAB don't actually know the difference, but it is a sensor pin. The LED pin right here, once again, this is LED pin D9. So if your circuit is not working, either change this to D13 or change your wire over to D9. Below, you see we set another variable here called threshold. What this variable is our threshold from when the LED turns on and off. If you're having problems and you're sure that your entire circuit is working, play around with this number a little bit, maybe make it higher or lower, and you should be able to get the light to turn on and off. After we have our variables defined, start our while loop. Once again, while it says 1, it will just run infinitely unless we do something to change that. In later labs, we set one more variable here, light value, or light val, equal to our read voltage. Read voltage we used in the previous lab, but this is a built-in function that will read the voltage of an analog pin. And we tell it to go to A. A is our variable Arduino. We tell it specifically to look at the sensor. These are the two things we send to the function. After that, we tell it to display another function, light value. This is the number we see down below that changes in our command window. From there, we start an if statement, and we set light value, we defined above. If this is below the threshold, then we want to turn the digital pin on. So we call out to the Arduino, tell it which variable that we use. So this is D9, and then we tell it to turn on. Else, and this is if none of the if or if else statements are correct, we tell it to turn the digital off. Then the if statement, and then in this case, that should be enough to get you going with the basics of this Tinkerkit. Go ahead and work through your Go Further challenge. And as always, if you have problems, please let me know and I'll see what I can do to help. Thank you.